SkySecure is designed to be a cloud-managed, secure, hyper-converged solution. What this means is Skyport is really designed to deliver a cloud experience for our end users. We're actually deploying a full-featured private cloud experience with our infrastructure. And what this means is that there's a cloud management component that allows you to deploy the service immediately. We likewise keep the system up to date. This minimizes the amount of maintenance required to maintain the overall system and all the associated services. Likewise, all of the services required to deliver secure hyperconverged compute are included in the system and are pre-assembled. There's no assembly required with Skyport. The cloud-based management infrastructure of Skyport allows you to deliver a self-service model for your users. In the end, the advantage for enterprises is this allows you to deliver the cloud experience your internal users already expect from cloud services within your enterprise. Specifically, SkySecure includes multiple components. First, there's a cloud-based management service, and there's an on-premises hardware component. This hardware component includes all the capabilities that you need to securely run individual virtual machines and build a secure environment. What's different is that Skyport started first with security. We include not only secure virtualization, but there's also hardware accelerated capabilities for things like software-defined networking and software-defined storage. And this also includes all of the other capabilities that you expect from a hyperconverged system, as well as an in-depth series of analytics and visualization capabilities that we'll take a look at in a moment. When you first log into the SkySecure system, the first thing you notice is what you don't have to build. In fact, this portal that you see here is already pre-configured and up and running as soon as you're a Skyport customer. In fact, there's no software to install or maintain on premises. This is something that Skyport delivers as a cloud service. It's always available, highly redundant, and also always up to date. When you deploy your first hardware appliance, it immediately becomes available inside the service. Now, the Skyport system is designed to be fully remotely manageable, and this is really what's fundamentally different between this and other types of solutions. The hardware appliance itself has a secure connection back to the cloud management service, and we use this not only for telemetry and management and control, but also we establish the identity of the platform and also validate the hardware integrity of the platform. As a user, when you plug in, you immediately see this level of telemetry. We can tell you all the information you need to know about uptime, what this system is running, individual resources that are in use on the system. And we also deliver extensive telemetry on all of the hardware components inside. This is a system that's designed to deploy remotely with no associated infrastructure, either to protect it or to enable management. In fact, this is designed to be as close as possible to a plug-and-play system, where as soon as it establishes a connection to the cloud management service, you don't need to physically touch it again. Now, inside the platform itself, this telemetry channel built into the SkySecure system is actually a secure hardware validation. This is based on Intel's TXT technology and actually features full remote attestation. For most of the end users, the only thing that you look at is this flag here which says the system is valid. But under the covers, Skyport has automatically gone through and validated the integrity of the hardware, the firmware or BIOS, as well as all of the software components inside the entire stack of the individual platform. And this is done on two separate pieces of hardware. There's the x86 compute hardware, as well as a hardware accelerated I/O controller. Both of these systems are actually fully hardware and software validated by the SkySecure platform. And all of this happens automatically. We can guarantee the integrity of the hardware, the firmware, and the software running on the platform, but we can also guarantee the unique identity of the platform. With the SkySecure system, you can actually drop ship a new appliance to a remote site. And when this comes up, the attestation process that works with the SkySecure system in the cloud management service will guarantee that the device has not been modified in transit, that this system is a high integrity system, that we actually can validate all of the hardware and software components. But more importantly, we can actually guarantee the identity of this system. In fact, if you're a SkySecure customer, you know that this can only be your device because it's cryptographically tied to the TPM chips inside of the hardware. This unique identity and remote attestation is a fundamental capability of the SkySecure system. With our existing installed base, we've already been able to detect potential hardware errors and actually proactively replace systems based just on this information that we're able to collect from the hardware. Likewise, the other capability of the SkySecure system is full management of the entire software stack. So this allows us to keep this platform in an evergreen state. It's always up to date and always ready to go. Once you have the system up and running, you can now deploy a new compartment or a new virtual machine in a secure environment inside the system. And we've designed this to do two things. One, to make this extremely streamlined and very fast to deploy, but also completely remotely manageable. But you could also securely build a new system in that area. So let's walk through actually building a new trusted component. Let's say this is something like an Active Directory domain controller. We're going to go ahead and deploy a new compartment. We're going to call this My New DC. Now, this new domain controller, in this case, is actually going to start off in an automatically created microsegmented environment. So I'm actually going to set this security posture to actually fully whitelist everything. And this starts before the VM is actually created. This is how you can actually do a secure build in a remote location. And in this case, I can either import an existing image if you have a known good golden image, or we can actually do a clean install from an ISO. I'm going to go ahead and do a clean install because this is a brand new system. I'm going to select Windows Server. In this case, let's pick Windows Server 2012 R2. What I'll point out is that this is actually designed to do a couple things. First of all, create the secure environment when you first spin up the virtual machine and actually make the experience as streamlined as possible. In fact, we're even hosting and validating the install media inside of our service. So in this case, when I click on Go, it's actually automatically going to pull down a valid boot ISO image, and we're going to test the actual SHA-2 sum of this image and guarantee the integrity of the install media as part of that installation process. Now let's take a look at the actual system when it's up and running. The first thing you'll notice is how streamlined the configuration is designed to be. This is to enable this self-service or cloud experience for your end users. With this system, you don't need a PhD in virtualization or even an advanced network configuration to securely deploy a highly available, highly secured system in a remote location. With this system up and running, the first thing you'll notice is we've automatically built in a secured network environment around the actual virtual machine. As soon as the VM is up and running, we've automatically attached to the network, and the software-defined network can actually detect things like local addresses present inside the system. You'll also notice that the security policy is actually part of the VM configuration. The reason we do this is so that as you move the virtual machine, the policy follows it. This Active Directory domain controller actually has a very simple policy. As you can see, it's starting off in this full whitelist posture, and we've created a simple rule that's going to allow Active Directory domain controller traffic and also Windows Update. And in fact, we've actually set up all of the best practice policy for all of the underlying protocols in Active Directory, and have also built the right rules to actually instantiate a proxy around the VM. So in fact, by deploying it with these simple entitlements, this domain controller was actually born in clean source. It started its life in a compartment where it was highly protected by microsegmentation and distributed firewall rules, and the only thing allowed into or out of the system are the authorized protocols for Active Directory, Windows Update, and NTP. This is actually how you can then build a secure system remotely. The SkySecure system also includes all of the components to remotely access and manage your individual protected virtual machines. In this case, it's also been built to be a completely cloud-based, toolless experience. In fact, what you see here is a virtual console that is built directly into the system, and as you can see, it's running entirely in the web browser. And as a result, it's actually highly compatible. This is a system that actually works even inside of a Chromebook. It doesn't require any local tools or other capabilities of the client to actually support this. And it's actually secured by the system itself. In fact, my connection to this system is automatically encrypted through TLS directly to the platform, and it's actually authenticated through the management service. This allows us to have a highly secured remote console interface directly into these systems without requiring any remote infrastructure to support this system. Now let's take a look at what some of the security protections can offer for even a critical system like a domain controller. And inside this domain controller, we've actually embedded a piece of simulated malware. In fact, I'm going to execute this piece of malware, and it's going to try to reach out to a command and control server. Now typically this is something that could actually devastate an Active Directory implementation. But inside the Sky Secure system, we can actually block this type of behavior. In fact, we can even control things like web browsing. We can, for instance, block access to external sites like CNN.com. You can see that it connects to Microsoft.com. However, it's actually stripped out all of the content in the site that did not actually come from the Microsoft.com domain. Now, that piece of malware that we launched actually was blocked by the system. And in fact, you can see all of the domain access that was actually disallowed by the proxy around that system. And in fact, here you can see the one place where that piece of simulated malware tried to reach out. And this was automatically blocked and reported by the system. Now this is just the first part of the virtualization and visualization capabilities of the system. All traffic that passes through the microsegmented network inside the Sky Secure system is also subject to visibility. What you're looking at now is actually a report of every conversation that this single virtual machine had in the past hour. Now this is powered both by collection in hardware inside the platform. There's custom hardware that actually creates and runs all the software-defined networking functionality inside the Sky Secure system. And this is powered by a web-scale reporting engine as part of the cloud management service. And what this allows us to do is offer a highly scalable view of all traffic going through every VM compartment. And what you see here is actually a report of all of the observed flows going into and out of the system. What Sky Secure also allows you to do is get visibility into the actual DNS FQDN used to create a flow. This is something that's highly unique inside the Sky Secure system. In fact, when we see traffic to a public address, in this case, if we look at the last entry here for 13.65.254.0, what this is actually showing you is this is a public address, and the reason why we're going there is because it originally did a lookup for time.windows.com, and it's an NTP flow, and it was allowed by policy. In fact, we can even tie it directly to the direct policy that allowed that traffic. This is a level of visibility and forensics that's built inside the system. Now, this is a view of all the traffic that's happened in the past hour. But because the cloud-based management service also allows us a tremendous amount of scale, we can go back in time. I'm going to go back in time more than a year ago. Let's pick April 11th through April 12th, 2016. And what this is going to do is actually pull up a record of every communication this system had. Now, it's important to stress that this is a live virtual machine running in a real system, running in the production instance of our management service. When I click run, you can see exactly how quickly this can come back with the information. This is now a report of every communication that this VM had over a year ago, on April 11th through April 12th, 2016. And as you can see, it's instantly available. This is the power of this level of visibility, but also traffic history. What this allows you to do is actually go back in time and troubleshoot things that could have happened in the past. If you're doing an incident analysis or remote troubleshooting, you can actually use this traffic visualization to actually understand who was talking to a virtual machine, whether connections were actually completed or whether they're one way. This type of visualization can even spot traffic that was dropped by an upstream firewall. It's also important to stress that this is always on. The reason we can offer this type of history is because it's hardware accelerated collection of the actual flow data and its cloud-based scale for the overall history of this traffic. Now, we've seen how far back it can go in terms of history, but this is just one piece of the visualization that we get. The same capability is also used to aggregate traffic and be able to provide extensive reporting in the overall amount of traffic that's gone through the system. In this case, we can actually limit it down to individual virtual machines or run all virtual machines at once. What this report is showing you is for a given time frame. Here we're going to pull it up for the past week. This is now aggregating all of the traffic data through each one of these systems, and this allows you to get extremely accurate accounting for all of the traffic that's gone through that system. We've also built in a level of threat and vulnerability scanning inside the platform. What you can see here is what we call our attack surface report. Inside the platform, we're continuously scanning the surface of each one of the protected virtual machines of the system, and we can actually report on exactly what was seen as open. This is an example of a Linux-based virtual machine that we use as a jump host for protecting administration for things like AWS CLI tools. And as you can see, we've scanned the surface of the compartment, and the only listening port here is port 22. What we can then do is actually associate this back with the individual policy that allows port 22, that it's learned through a port scan, but also that there's an entitlement to allow traffic in. And we can even show you and go back and correlate with all the flow information as to whether any traffic has actually been observed coming into the system. On top of this, we've also built in a policy monitoring capability here as well. For every policy that's created on the system, there's a lifetime associated with that policy. So you can actually go in and audit who created that policy, when and where, and how does it affect traffic coming into and out of the system. SkySecure also has some advanced traffic analytics capabilities. Through what we call our Traffic Insights capability, we also have the ability to decode protocols all the way up to layer 7. And in this case, we've started by targeting some of the key Active Directory protocols like Kerberos and RDP. And in fact, what this allows us to do is provide complete audit trails for underlying protocol interactions inside each one of the compartments. What you're looking at here is an audit trail of all of the Kerberos authentication transactions that have happened inside the system. And this is something you can enable on a per VM basis, and it's an extremely powerful capability to protect critical systems and applications. Now, everything that you've seen here is part of the SkySecure system. This is something that you can deploy remotely. It's something that you can have up and running in a very short amount of time. We typically find that our end users can have a system from a sealed box to up and running a protected virtual machine, usually in less than an hour. And the reason we can do this is because of the cloud experience that this brings. All of the management software, all of the capabilities that drive the scale of this system, all the included microsegmentation, the firewalling, the software-defined networking and storage, all of this is built directly inside the system and does not require any assembly. Likewise, all of these components are always up to date and do not require any maintenance. This is all part of the overall system. And this is the experience that you get from Skyport.